Good morning, students. The last session we discussed about various classification of colloids. That is three types of classification. First one based on the physical state of dispersed phase medium. 8 groups are there. Second, based on the interaction or affinity between dispersed phase and the medium, 2 types. One is lyophilic and lyophobic. And the third type, based on the nature of particle, that involves multimolecular, macromolecular and associated colloid. In that associated colloid, you studied detail about the formation of micelles and formation of micelles by taking soap as an example. And also, we conclude last session by explaining how does the soap act as a cleansing agent or cleaning action of soap. And the next type, here, next we discuss about the preparation, various type of preparation of colloids. Based on the affinity, there are 2 types of colloid. One is lyophilic, other lyophobic. Lyophilic salt, example starch salt or protein salt, they can be easily prepared just by mixing or warming with the dispersion medium. While this lyophobic salts, in that case we explain it as lyophobic salt require certain special method. Then, what are the special methods used for the preparation of lyophobic salt? The preparation of lyophobic salt mainly involves 2 types. One is called the dispersion method. Dispersion method. The dispersion method. In dispersion method, the huge blocks of substance are converted to particles of colloidal size. That is, lumps of the substance are converted to colloidal particle that involves in this method or dispersion method. And in dispersion method, we deals with electrodispersion method. Electrodispersion method, or it is called Briggs arc method. Electrodispersion method, that is the conversion of huge blocks are converted to colloidal particle by using electric arc. That is called electrodispersion method or Briggs arc method. I represent this method by using a pictorial way, and after that I explain. That is, here these 2 represent gold electrode. Gold electrode. That gold electrode is immersed. That is dipped in water containing alkali, KOH or NaOH, and it is immersed in a freezing mixture. It is immersed in a freezing mixture. That is, here 2 gold electrodes are there. When an electric arc is applied between 2 gold electrodes dipped in water containing alkali. Okay, clear? 2 gold electrodes, high intensity electric arc or high intensity electric current is struck, applied between 2 gold electrode dipped in water containing alkali. Due to the intense heat of the arc, this metal undergo vaporization or the metal vaporizes, and they readily condenses into, these vapors are condenses into colloidal particle since it is immersed in a freezing mixture. The function of alkali along with water is to stabilize the colloid. Clear? That is once more. In dispersion method, the lumps of the substance, huge blocks, are converted to particles of colloidal dimension or colloidal size. And the first one belongs to electrodispersion method or Brady's arc method. A high intensity electric current is applied between two gold electrodes dipped in water containing alkali. KOH is one of the example. Any alkali we can take. Due to the intense heat of the arc, this metal vaporizes and that vapors are condensed in the form of colloidal particle since it is immersed or dipped in a freezing mixture. The function of alkali is to stabilize the colloid. That is the principle behind this Brady's arc method. Sometimes question asks only this electrodispersion method, or it is also known as Brady's arc method. And the next method is peptization. That is, second method is peptization. Peptization. That is, in the introduction of this topic, that is colloid, we say that there are three types of system. Homogeneous system having particle size less than 1 nanometer, that is called a true solution. Heterogeneous system having particle size greater than 1000 nanometer, that is called a suspension. And in between 1 to 1000 nanometer, a heterogeneous system formed, that is called a colloid. Here, peptization is the process of conversion of a precipitate into colloid is called peptization. That is, the process of conversion of a suspended particle into colloidal particle is called peptization, and the reagent used for that conversion, of the suspended particle into colloid is called a peptizing agent. It is called a peptizing agent. Okay, you can easily understand. If we take ferric hydroxide precipitate in a beaker, that is ferric hydroxide precipitate taken in a beaker, it dissociates into, that is Fe3 plus and OH minus ions are there. That is, initially it is in the form of a suspension or a precipitate. To that we add ferric chloride, FeCl3 is added. By the addition of FeCl3, it also provides Fe3 plus ions, or Fe3 plus ions are produced from this ferric chloride. As a result, what happens? The total concentration of Fe3 plus ions in the container or beaker increases, and the like charges tends to repel each other. That is, this suspended particle disintegrate, or the precipitate changes to colloid by the addition of ferric chloride, which act as peptizing agent. Okay, generally the conversion of a suspended particle or a precipitate into colloid is called a peptization. The reagent, there are certain reagent with the help of which we can convert that precipitate into colloid, and that reagent used for this conversion is called a peptizing agent. Here initially we take ferric hydroxide precipitate in a beaker. It contains Fe3 plus ions, and by adding ferric chloride, which provides Fe3 plus ion, the concentration of Fe3 plus ions increases. As a result, the like charge tends to repel each other, or the precipitate disintegrate to form colloid, where ferric chloride acts as peptizing agent. That is the first method called dispersion method. And the second method for the preparation of colloid is called a condensation method. Condensation method mainly involves the chemical method for the preparation of colloid. And the different types of condensation method are oxidation method. In oxidation method, colloidal sulfur is prepared by passing sulfur dioxide through an aqueous solution of hydrogen sulfide. When sulfur dioxide gas is passed through an aqueous solution of hydrogen sulfide, we get colloidal sulfur. That is, sulfur salt is obtained. That is the oxidation method. Second one is just the opposite of this oxidation, that is reduction. Gold salt is prepared by the reduction of auric chloride by using aqueous solution of formaldehyde. By using an aqueous solution of formaldehyde, these auric chlorides are reduced to gold salt, AU, gold salt, HCOOH or methanoic acid plus HCl. That is, HCHO means methanol or formaldehyde. Aqueous solution of formaldehyde treated with the auric chlorides, we get colloidal salt. And by hearing this, suddenly a doubt arises, and somebody think that in the first case, that is about dispersion method, we explained that gold salt is prepared by dispersion method or electrodispersion method. Here, condensation method, gold salt can also be prepared by condensation method. If a question asks like this, that is, gold salt can be prepared both by dispersion as well as condensation method. Comment on that statement. Obviously, this gold salt can be prepared by both method, dispersion as well as condensation method. And the third method of this condensation is hydrolysis method. That is hydrolysis. Hydro, usually splitting using water, that is called a hydrolysis. Here, ferric hydroxide salt is prepared by adding hot water to ferric chloride. hot water is added to ferric chloride drop by drop till a reddish brown color is just formed. Okay, if we add large amount of hot water to ferric chloride, the final product formed is ferric hydroxide precipitate, not colloid. In order to get ferric hydroxide salt, we add hot water drop by drop to ferric chloride till a reddish brown color is just formed. That is hydrolysis method. And one more method in condensation, that is nothing but double decomposition method. Double decomposition. Double decomposition method. Normally arsenic sulfide salt is prepared by passing hydrogen sulfide through an aqueous solution of arsenic sulfide salt is prepared by passing hydrogen sulfide through an aqueous solution or through arsenic oxide, or by the passage of hydrogen sulfide through arsenic oxide. The product formed is arsenic sulfide salt. Mainly there are four methods in condensation. One is oxidation, where sulfur salt is prepared by passing sulfur dioxide through an aqueous solution of hydrogen sulfide. Gold salt is prepared by the reduction of auric chloride by using formaldehyde, aqueous solution of formaldehyde. Ferric hydroxide salt is prepared by adding hot water to ferric chloride till a reddish brown color is just formed, and arsenic sulfide salt is prepared by passing hydrogen sulfide through arsenic oxide. These are about the method of preparation, that is the preparation of colloid. Preparation of colloid, there are two methods. One is dispersion method and other is condensation method. Dispersion method and the condensation method. Dispersion method, that belongs to types. One is Bredik's arc method, or electrodispersion method, and peptization. In Bredik's arc method, a high intensity electric current is applied between two cold electrodes. That electrode is dipped in water containing alkali. Due to the tremendous amount of heat produced from the arc, that metal vaporizes. At the same time, they condenses into colloid because it is immersed in a freezing mixture. Alkali is added to stabilize that colloid. Peptization is suspended particle is converted to colloid, or a precipitate is converted to colloidal particle, and the reagent used for that conversion is called a peptizing agent. Condensation involves oxidation, reduction, third one hydrolysis, fourth one is double decomposition. That is the condensation method. Okay. Next about colloid prepared by this method, dispersion as well as condensation method, is usually contaminated with ionic impurities. Ionic impurities and crystalloids. Colloid prepared by this method are not pure. That is, mostly it is contaminated with this ionic impurities and crystalloid. And the next is, what are the different methods for the purification of this colloid? That is, the impure colloid is converted to pure colloid. That is called a purification. How that purification is carried out. And the first method for purification is dialysis. Dialysis. So I think you are familiar with this word, dialysis. If a person is suffering from some kidney problem, which is the major excretory organ in our body, artificial purification is conducted by using a process called dialysis. And also, you know that snake venoms are of two types. One is hemotoxic and other is neurotoxic. Hemotoxic venoms, the venom produced from cobra, kite, etc., directly affect the central nervous system, where the venom from viper affect the circulatory system, which is called hemotoxic venoms. During the bite of this viper, this poison get circulated in our blood or affect the circulatory system, and finally kidney becomes damaged. In such situation, we apply this process called dialysis, because blood is a colloidal system. And here we discuss about what is the principle of dialysis. In dialysis, the impure colloid is taken in a cellophane bag. Impure colloid is taken in a cellophane bag or a parchment paper, just like our semi-permeable membrane discussed in the case of osmosis. The impure colloid is taken in a cellophane bag or a parchment paper, which is suspended in flowing water. And dialysis is based on the principle that only the impurity can diffuse through the bag, while pure colloidal particle remains inside. That is the principle of dialysis. Only the impurity can diffuse through the cellophane bag, while pure colloidal particles remains inside. Dialysis is a slow process, and nowadays the rate or speed of dialysis can be increased by placing 2 electrodes outside the membrane. When 2 electrodes are kept outside the membrane, the rate of dialysis increases, that is, the purification of blood becomes faster, and such a dialysis is called electrodialysis. That is electrodialysis. One of the purification method. Why colloid is to be purified means, it normally the colloid prepared by either condensation or dispersion method normally contains ionic impurities and crystalloid. And these impurities are purified by using different technique. First one is dialysis. In dialysis, the impure colloid is placed in a cellophane bag or a parchment paper. It is suspended in a flowing water, and the basic principle of dialysis, don't confuse that, only impurity can diffuse or pass through the bag, while pure colloidal particle remains inside. In order to increase the speed of dialysis, 2 electrodes are kept outside the membrane, and such a dialysis is called electrodialysis. Nowadays, this electrodialysis is applied. Anyway, the process of dialysis, depending upon the health of that patient, it will take nearly 4.5 to 6 hours. for completing the process. Okay, that is dialysis. Second method for the purification is ultrafiltration. Ultrafiltration. You know, size of the colloidal particle is too small so that ordinary filter paper cannot be used for the filtration of colloid. Ordinary filter paper are not fit for the filtration of colloid because the pores are large enough for the passage of colloidal particle. The size of the pores are large enough for the passage of colloidal particle. If we minimize or reduce the size of ordinary filter paper, they can be used for the filtration of colloid. If we reduce or minimize the size of the pores of this ordinary filter paper, they can be used for the filtration of colloid. Such graded filters are called ultra filters. They are called ultra filters. Ordinary filter paper can be converted to ultra filters by pasting with by impregnating with a substance which is called collodion. Collodion, by pasting with or impregnating with the collodion. Collodion is a mixture of 4% nitrocellulose, 4% nitrocellulose in ether and alcohol. That mixture is called a collodion. If the proportion of nitrocellulose varies, they cannot be used as ultra filters. Ordinary filter paper, when this mixture is pasted over this ordinary filter paper, that filter paper can be used for the filtration of colloid. Such filters are called ultra filters. And normally it is made hard by using formaldehyde. 1 marks question or 2 marks question of this type. Collodion is usually used in ultrafiltration. Collodion is usually used in ultrafiltration. What is collodion? Your answer is collodion is a mixture of 4% nitrocellulose in ether and alcohol. It is a mixture of 4% nitrocellulose in ether and alcohol. That mixture is called a collodion. It is used to minimize the size of the pores of ordinary filter paper. Okay. And one more method is there, but in our textbook only these two methods are explained. You know, ultracentrifugation. Ultracentrifugation. If he is suffering from some kind of fever, like a dengue fever or malaria like that, the blood is a colloidal system. That sample of blood is taken in a high-speed centrifuging machine. High-speed centrifuging machine, and the pure colloidal particle settle and the centrifugate contains impurity. When that centrifugate after the removal of that centrifugate, when it is mixed with the suitable dispersion medium, that pure colloidal particle generate. Okay, these are about the purification of colloid. And based on this, up to this, you take some questions, that is differentiate lyophilic and lyophobic salt. Example of multimolecular colloids is dash. So what are associated colloids? What are associated colloids? Explain the mechanism of the formation of micelles. Formation of micelles. How does soap act as a cleansing agent? How does soap act as a cleansing agent? Explain the following terms. Briggs arc method, peptidization. Briggs arc method, second one peptidization. What are the different types of condensation method? What are the different types of condensation method for the preparation of colloid? For the preparation of colloid. What is the basic principle of dialysis? Basic principle of dialysis. What do you mean by electrodialysis? What do you mean by electrodialysis? What is ultrafiltration? What is ultrafiltration? Collodion is usually used in ultrafiltration. Collodion is usually used in ultrafiltration. What is collodion? What is collodion? Or these are the important questions normally asked for the examination from this topic. And next area, that is First of all, we understand what is a colloid. Next, how are they classified? And then different method for the preparation of colloid. That prepared colloid, how to purify that colloid. And the next area, we discuss about the properties of colloid. What are the different properties exhibited by colloid? If you have any idea about the properties of colloid, okay, that part we discuss in the next class in detail. Okay, thank you all.